Good morning, students. Today we are going to discuss few topic from chapter 4, and the chapter 4 is your motion in a plane. Now the first topic which we are going to discuss, position and displacement vector in plane. So related with the vector, we have not discussed position and displacement. Now as plane define infinite direction, that's why we have to define position and displacement in terms of vector to specify a particular direction. Now you see this diagram. This is your xy plane, and on the plane you do have two point, or you can say position. Now at A is the position whose position can be defined by the position vector, that is your r1 vector, and B is the position which can be defined by the position vector r2 vector. So already we have defined position vector. For position vector, you need a reference point from where you have to define the position. Now you can consider this diagram by considering an object is moving, and it is at A when the position vector is r1 and the corresponding time is your t1, and after a certain time let the position of the object be at B, which can be defined by the position vector r2 vector, and the corresponding time is your t2. So delta r vector or AB vector can be defined as your change in position. So component part already defined, the vector component part, as r1 and vector and r2 vector does not have any specific direction, neither it is along x-axis nor it is along y-axis, so it has this component both x and y. Now if r1 vector is along x-axis, then it is along x direction, so it does not have component, then it is only one parameter, that is x-axis. Now as r1 vector and r2 vector is not along x direction or y direction, but it is in the plane comprising xy, that's why it has this component. Now the component part already we have discussed, rectangular component. So let me define r1 vector in terms of component. So x1 I cap, y1 j cap. So x1 I cap is your component along x-axis, and y1 j cap is your component along y-axis. Similarly, r2 vector has this component x2 vector, x2 I cap plus y2 j cap. Now if you have to apply triangle law in this figure, so r1 vector and delta r vector is in continuous direction, but r2 vector is in opposite direction. Opposite direction is in the sense that it is not in continuous direction. So you can apply triangle law, and what the triangle law says, it says that sum of the two vectors which are in continuous direction should be equal to the third vector which is in opposite direction. So r1 vector plus del r vector equal to r2 vector. Del r vector is nothing but the change in position, you can say. So delta r vector equal to r2 vector minus r1 vector. So as delta r vector in the xy plane, so it has its component along x-axis and y-axis. So let the component be delta x I cap plus delta y j cap, and correspondingly r2 vector and r1 vector, let me substitute the value, that is your x2 I cap plus y2 j cap minus x1 I cap plus y1 j cap within bracket. So let me arrange the I cap part, x2 minus x1 I cap and y2 minus y1 j cap. Now you can compare both sides. If you compare both sides, then delta x is your x2 minus x1 and delta y is your y2 minus y1. So here AB vector is nothing but the delta r vector, and that is nothing but the displacement of the particle in the time interval t2 minus t1. Now related with this one, let me try to define the velocity of the particle. Now already we have defined that an object is moving and it is at position A corresponding to the r1 vector. Within bracket we have written t1. It means r1 vector is the position vector of the object at A in time t1, and after a certain time it has its position at B corresponding to the position vector r2 vector in time t2. Now if you have to define velocity at point A, so what you have to do, you have to draw a tangent on the path. The path is your curved path, is moving A to B, and the diagram is almost like this. We have not shown the path here, we have shown a change in position. So if the path is curved, then the tangent at that point gives the direction of the velocity. So let me define The diagram is almost same. You can draw this diagram here also. So average velocity is nothing but is your delta r vector by delta t. Delta t is your t2 minus t1, and delta r vector is nothing but is your AB vector, as in this figure. Now you can get the instantaneous velocity from average velocity by considering the limit delta t tends to 0. So limit delta t tends to 0 is nothing but v vector del r vector by del t. So you can split this one in terms of component. Del r vector is nothing but is your delta x I cap, delta y j cap. So here delta x, delta t I cap, limit delta t tends to 0, delta y, delta t j cap. So already you have discussed the instantaneous velocity part. So you can write dr dt and dx dt I cap, dy dt j cap. So dr vector dt is nothing but the instantaneous velocity, velocity at an instant time t1 you can consider. Vx is your dx dt and Vy is your dy dt. So it has this component, and already I have written v vector equal to dr dt, r vector dt, Vx equal to dx dt, and Vy equal to dy dt. So whatever be the vector in the plane, it has this component along x-axis and y-axis. If the discussion considering 3 axes x, y and z, then definitely it has another component along z-axis. Now acceleration of the particle, let me consider this diagram again. So r1 is the position of the particle at a corresponding time t1, and r2 is the position vector of the particle when it is at b corresponding time t2, and instantaneous velocity you can get by drawing tangent at that specific point. And let me try to draw the diagram here. Making parallel to v1 vector, we have drawn a vector in down, and making parallel to v2 vector, we have drawn in down. Now corresponding to v1 and v2, as the change in velocity is from v1 to v2, so another side of the triangle is your delta v vector, and it moves from v1 to v2. That's why the direction is from v1 to v2. Now if you apply triangle law here, again you will get v1 vector plus delta v vector equal to v2 vector. Now here a change in velocity, so average acceleration is your del vector, del v vector, del t. Del t is your t2 minus t1. T1 is the position corresponding to r1, and t2 is the position corresponding to r2. T1 is the time corresponding to the position r1, and T1 is the time corresponding to the position r1, and T2 is the time corresponding to the position r2. Now instantaneous acceleration you will get just instantaneous velocity, limit delta t tends to 0, delta v vector del t, limit delta t tends to 0. It has this component again along x-axis, delta vx we have considered the component along x-axis I cap, and delta vy is the component along y-axis, that is j cap. Now if you apply the formula instantaneous velocity, then it is your db vector dt, dbx dt I cap, dvy dt j cap. So db dt is your a vector, that is instantaneous acceleration, and that is your acceleration, instantaneous acceleration along x-axis ax, and ay is your instantaneous acceleration along j-axis, means y-axis, that is your j cap. So whatever be the vector in the plane, it has this component along both the axes, that is your x-axis and y-axis. So please go through this topic. Initially it seems to be very tough, but once you understand, it's become very easy. So please go through, and also compare your topic with your previous topic, so that it's easy to understand for you. So this is all about for this class. So please find out your doubts and ask question. Thank you.